Hello everyone, this is Vidhi Patidar, third year integrated MSc Physics student at IIT Roorkee, and today I will be presenting the presentation on the topic Capacitive Transducers under the coursework's PHN 310 Applied Instrumentation. So these are the following topics that I would be covering in my presentation. So first of all, let's start with understanding with the definition of the capacitive transducers. So they are basically a type of transducers which measures a change in capacitance, uh, which means the ability of two conductive surfaces to store electrical charge in response to a physical phenomena such as pressure, displacement, or acceleration. So this is the basic diagram of a capacitor which consists of two conductive plates and which have a dielectric material in between. The dielectric material can be conductive or non-conductive or can be vacuum as well. So the area of the plates and the thickness or the distance between the two plates determine our properties that we will measure in the following section. So basically we have three types of capacitive transducers. Broadly they are differential, absolute and variable capacitive transducers. So let's understand the difference between these following. So they all are designed to measure the change in distance or displacement between the two surfaces. The absolute capacitive transducers, as the name suggests, measures the absolute value of these changes. So the differential capacitive transducer, it consists of one fixed and one movable plate. And the absolute capacitive transducer consists of a single plate which is separated from a conductive backing of a dielectric material. And the variable capacitive transducer, it have a movable diaphragm which changes the capacitance between the two plates as it moves. So their operation is as follows. In the differential capacitive transducers, we can measure the change as the distance between the two plates will change. Same follows for the absolute capacitive transducers and the variable capacitive transducers. So by measuring the change in the capacitance, the displacement or the physical phenomena that we were measuring can be measured. So they have different applications in various fields such as differential capacitive transducers have their applications in the micro and nano positioning applications in semiconductor manufacturing and microscopy. The absolute capacitive transducers, they find their applications in weather stations and the HVAC system and medical devices, etc. The variable capacitive transducers, they are used in pressure and acceleration. They are used as pressure and acceleration sensors in the automotive and aerospace industries as well as in the temperature sensors. So now let's understand the working principle of the capacitor. So mathematically, the expression of the capacitance between two conductive plates is expressed as C equals to epsilon A by D, where C is the capacitance, epsilon is the permittivity of the dielectric material between the plates, A is the area of the plates, and D is the distance between the plates. So there is an influence of dielectric material and plate geometry as we can see from this mathematical expression. So different dielectric materials will have different permittive values which will affect the capacitance of a transducers, and similarly the plate geometry, the shape and size of the plate will also affect the capacitance. As we can see that A is directly proportional to C. So as the area of the plate will increase, it will increase the capacitance values and vice versa. And there is also an effect of physical quantities on capacitance. So various physical deformation may occur because of pressure, strain or displacement. So the relationship between the physical deformation and change in capacitance is determined by the design of the transducer and the material properties that we are using for the plates and the dielectric material. And the fourth point is the explanation of the electronic circuit. So it will require an electronic circuit to measure the change in capacitance into an output signal, so that we can measure it and analyze it for our results. So typically a transducer is connected to a single conditioning circuit which amplifies and filters the signal to remove any noise or unwanted signal which are present. So output signal from the conditioning circuit is then sent for the data acquisition for further processing and analysis of the data. Now let's move on to the next part of the presentation, which are the applications of capacitive transducers. So first and the foremost important applications is in the touch screen. So they are widely used in electronic circuits, in electronic devices such as in a smartphone, tablets and laptops. So the touch screen consists of a transparent conductive layer which covers the screen. So whenever we press our finger or we touch the stylus with the screen, it changes the capacitance between the two conductive layer and the underlying screen. So this change in capacitance is detected by the touchscreen controller, which then translates it into a touch event. Their next application is the proximity sensors. So they are used in many industrial and commercial applications such as in automotive and home applications, manufacturing industries. So these sensors detect the presence of nearby objects by measuring the change in capacitance between the two conductive plates. So when you place an object near to the sensor, it changes the electric field between the plates, which results a change in the capacitance. And this change in capacitance is detected by the sensor and is used to trigger an event such as let's say turning on the light or opening a door, etc. The next application is in the measurement of as a pressure sensor. So they are used to measure the pressure of gases or liquids in a wide range of applications, including aerospace, automotive, and medical industry. So these sensors consist of a diaphragm that deforms when pressure is applied, changing the distance between the two conductive plates and hence resulting a change in the capacitance. So by measuring this change in capacitance, the pressure can be determined. Their next application is in the displacement sensors. They are used to measure the position or displacement of an object with very high accuracy and resolution. These sensors consist of two conductive plates which are separated by a dielectric material. So when the object being measured moves, the distance between the plates will change, which will result a change in the capacitance. So by measuring this change in capacitance, the position or displacement of the object can be determined. Their next application is as the humidity sensors. So they are used to measure the relative humidity of air in a wide range of applications including weather monitoring, HVAC systems and food processing. For that we use absolute capacitive transducers as I covered it in the previous part of the video. So these sensors consist of two conductive plates which are separated by a hygroscopic material. Hygroscopic material is used so that it can absorb or deabsorb the moisture from the air, which results a change in the capacitance. So by measuring this change in the capacitance, the relative humidity can be determined. Now let's move on to the next part of the presentation, which is the design consideration. So some of the key design consideration that we should make to ensure an accurate and reliable operation of the devices. First is the electrode geometry. So electrodes can be designed as parallel plates, cylinders, or maybe in other shape of the geometry depending on the specific application. So the distance between the electrode and the size of the electrode should be chosen very carefully to achieve the desired sensitivity and linearity. Second is the dielectric material. So the dielectric material, as I mentioned above previously, it can be air, vacuum or any solid material depending on the application to achieve the desired capacitance and sensitivity. The third consideration that we make is in the single conditioning circuitry. So the design of the single conditioning circuitry must be carefully chosen to minimize the noise and distortion in the output signal. The fourth is the temperature effect. So to minimize the temperature effect, the transducers can be designed with a temperature compensating circuitry, or basically using the temperature sensors which can be integrated into the design. Next point is the environmental effects. So to minimize the environmental factors such as humidity, pressure, and electromagnetic interference, the transducers can be designed with shielding or other protective measures. And one of the foremost consideration that we make is in the manufacturing. So the design of the transducers must also be taken into the account, such as the choice of material, the fabrication technique, and the assembly process. So this should be done to be robust and reliable, and the manufacturing process should be optimized to minimize the variability in the performance of the device. Now, let's have a look at the advancement and future prospects that the capacitive transducers may have. So, first point is in the micro fabrication techniques. So, my advances in micro fabrication techniques have enabled the miniaturization of capacitive transducers, which allows their integration into smaller devices and systems. So micro fabrication techniques such as in micro electromechanical systems have also enabled the development of capacitive transducers with higher sensitivity and resolution. The next is in the material science. So the development of new materials with desirable properties such as high dielectric constant, low thermal expansion coefficient, and high mechanical strength has enabled the development of more robust and reliable capacitive transducers. So new materials such as graphene and other 2D materials are also being investigated for use in capacitive transducers. Third is in the wireless communication. So advances in wireless communication technologies have enabled the development of wireless capacitive transducers, which can transmit data wirelessly to a receiver. So this eliminates the need for a physical connection, making the transducers a very versatile and easier to use in remote or difficult to reach locations. Um, and next is in the integration with other technologies. So capacitive transducers can be integrated with other technologies such as sensor, actuator, and microcontroller, allowing for the development of more complex and intelligent systems. For example, capacitive transducers can be integrated with microcontrollers to create smart home applications or integrated into robotic system to provide feedback on the position and movement. And one of the key advancement point can be in the biomedical application. So they are being investigated for use in biomedical applications such as in monitoring vital signs, detecting any disease or drug delivery. So the high sensitivity and accuracy of capacitive transducers make them attractive for use in these applications, and ongoing research is exploring new ways to use them in the medical field. So these were the following references that I used for the reference purpose, and I hope this video was helpful. Thank you.